Okay, guys, here is the video for these 5 problems we made up at the end of class and my attempts at the solutions. Let's see if I did these guys right. Okay, so starting with the first one. We want to solve x squared. So immediately I recognize that this is a quadratic equation. Minus 12x plus 14 equals 0. If I wanted to do quadratic formula, I could, but this is an ideal case for completing the square. So I'm going to subtract my 14 over, leave my x squared and my 12x, my minus 12x on the left side, equals 0 minus 14 is negative 14 on the right side. Mentally, I'm going to take half of negative 12 is negative 6. And then when I square that, I'm going to get plus 36, but to both sides. On the left side, this is going to factor as x minus 6 squared, because negative 6 times negative 6 is that positive 36. And 6 minus 6 is that negative 12. And that is going to equal, on the right side, when I simplify that, I get 22. So now something squared equals a number. I can do square root property right here. This is me using a square root to get rid of squaring. So I need to take the plus or minus square root. I need to consider both possibilities. And more or less, the squaring and the square rooting cancel. So I have x minus 6 remaining on the left. And then I consider the square root of 22. Now I know that 22 is like the square root of 2 times the square root of 11. But that's all I can think of as far as factors of 22 go. And neither 2 nor 11 are perfect squares, so nobody cares. So they're gone. And so the square root of 22 is just that. Plus or minus the square root of 22. I'm going to add that 6 over, shove it in front of that plus or minus. So x equals positive 6 plus or minus the square root of 22, which is what I got. All right, I got the first one right. Awesome. Number 2. We wanted to simplify 40 minus the square root of negative 96 divided by 54. Pardon my handwriting. I'm going to focus on the square root first. I don't know. Maybe I use technology. Maybe I just know this as a fact. 96 is not a perfect square, but I want to find the largest possible perfect square factor. So I'm going to run my list real quick. My perfect squares are 1, but nobody cares about 1, 4, 9, 16, 25, 36, 49, 64. And it's at some point we get too big and it doesn't become a meaningful number. So I'm going to start at 64. And I'm going to go, okay, 96 divided by 64, is that a whole number? And it's not. So then I do 96 divided by 49. Is that a whole number? And it's not. 96 divided by 36, is that a whole number? It's not. 96 divided by 25, not a whole number. 96 divided by 16, boom, we got it. So it turns out that 96 is 16 times 6. So this means I can do a couple of things. First thing, as you guys probably already saw, is I'm taking the square root of a negative number. So I'm going to be able to pull out an I, pardon my arrow. So I'm going to pull out an I, but then the next thing I'm going to do is I'm going to split up that square root of 96 as the square root of 16 times the square root of the other 6. And I'm going to divide that by 54. So square root of 16, that's a nice perfect square. He's going to come out as 4 times that leftover I, that's square root of 6, divided by 54. Okay, so if this is me doing it my way, I would then look at the 40, the 4, and the 54. My outside numbers, are they all divisible by something in common? They are. The biggest number that they're all divisible by is 2. So I'm going to divide them all by 2. And I'm going to come up with 20 minus 2i square root of 6 divided by 27. And between you and me, if that is what you put, that is a perfectly correct, good, beautiful answer. If you've already gotten in the MyMathLab habit, when you have an imaginary number of splitting it up and putting it in standard form, then this becomes 20 over 27 minus, and then here nobody cares where the I ends up, as long as it ends up somewhere. So you could write 2i square roots of 6 over 27, or you could put the I at the end, or even less conventionally, you could put the I in front of the 2. But again, nobody really cares, especially the person who grades your test, me. But you're welcome to write your answer either way here. All right, number 3. We want to solve, number 3, we want to solve -3 is less than or equal to 6 minus x over 4 is less than 11. All right, I see fractions. So the first thing I want to do, because this is an inequality, is I want to clear fractions, and I'm going to multiply everything by 4, because 4, by virtue of being my only denominator, is my lowest common denominator. Okay, so this is going to pop up later, but I did just multiply my inequality by a number, but because it's a positive number, nothing flips. Less than or equal to stays less than. Less than stays less than. Otherwise, dividing by 4 cancels with multiplying by 4, and I have 6 minus x in the middle. Neither the left nor the right had fractions, so nothing's going to cancel there. 4 times -3 is -12. 11 times 4 is 44. All right, next thing I'm going to do is I'm going to subtract that 6 off, but cardinal rule, whatever I do to one part of this, I have to do to all 3 parts. So I'm going to subtract 6 here and here as well. -12 minus 6 more is -18. Stays less than or equal to. 6's cancel. I'm left with -x. Stays less than. And then 44 minus 6 is 38. But I have not solved for x yet. That is still -x. Or if you prefer to think of that as -1x, we can. But to get rid of that negative, one way or another, I've got to either multiply or divide by -1. I think most of us would intuitively think to divide by -1. But there it is. I did just divide by a negative number. So I've got to turn my inequality symbols around. This becomes greater than or equal to, and this becomes greater than. -18 divided by -1 is +18. The negatives, and even the ones, if you prefer, cancel, leaving me with x. And then +38 divided by -1 is -38. And I just don't like the way this is written, so I'm going to turn this all the way around. My smallest number is this -38. So if I turn this around and start with -38, then I've got to use that greater than, which I'm going to turn back around to make it less than, x, and then I'm going to turn this greater than or equal to around here to become less than or equal to. And then I'm going to finish with that 18. So the picture of my solution set is x can be any value in between -38 and +18. So I can shade anything in the middle there. It cannot include -38, so parenthesis, but it can include 18, so square bracket. And my final answer in interval notation, parenthesis, -38, comma, 18, square bracket, and that's just about the only correct final answer. As a reminder, if you didn't turn stuff around and you wrote this as square bracket 18 down to negative 38 with a parenthesis, I'm going to dock you points for that. It's always got to be smallest to largest. All right, number 4. We want to solve the square root of 2x minus 5 minus 2x equals negative 5. So that's a radical equation. I see square roots. Step 1, isolate. A radical, well, there's only one, but I'm going to isolate by adding this 2x over to the other side. Those are not like terms on the right side. So the simplest thing I can call that is positive 2x minus 5 equals the square root of 2x minus 5. I'm going to get rid of squaring. I'm going to get rid of square rooting by squaring both sides. And that is going to require me to FOIL this business out on the right-hand side. So let me make some room. 2x minus 5 is what remains on the left, equals 2x minus 5 times 2x minus 5. And let me just kind of pause here in case you're wondering. It is sort of coincidental that we have all these 2x minus 5s. Let's not dwell on that. Let's just stick to the process, the algorithm. So I'm going to FOIL 2x times 2x is 4x squared. 2x times a negative 5 is a minus 10x. Minus another, there's my x, minus another 10x, plus 25. Why do I keep forgetting that x? Equals this 2x minus 5 on the left. This is a quadratic equation, so I want to get this in standard form so I can do quadratic formula or factoring. But that means I've got to combine these like terms here in the middle. So 4x squared minus 20x plus 25 equals 2x minus 5 on the right. On the left. I keep getting those mixed up. I'm not in standard form yet, so I'm going to subtract 2x from both sides, add 5 to both sides, and I'm going to end up with 0 equals 4x squared minus 22x's plus 30. All right, I can do the quadratic formula right there and now, but for my own sake, I know that things are easier if I've got smaller numbers, and I notice that all of those numbers are even. So I'm going to divide out a 2, more or less, from all my terms. This is a way to do it, and it's a legal way to do it in this circumstance. So 0 equals 2x squared minus 11x plus 15. Still a quadratic equation, and it is in standard form, and it probably will factor. And if you want the challenge, go ahead and factor it. But I'm going to go ahead and do quadratic formula because I feel like that's probably what most of us would do from this point. So really quickly, I'm going to note that A equals 2, B equals negative 11, and C equals 15. And I'm going to have to go to the next slide. So take a mental image of those numbers. Well, actually, I'll just start with that again. So if I check the 3, let's recall that the original equation was the square root of 2x minus 5 minus 2x equals negative 5. So square root of 2 times 3 minus 5 minus 2 times 3, does that equal negative 5? Well, 2 times 3 is 6. 6 minus 5 is 1. So remember, the square root of 1 is an actual number. It simplifies. The 2 times 3 that's there is 6. Does that equal -5? Well, the square root of 1 is 1. 1 minus 6 is -5. It checks. Haha. So what about 5 over 2? And I know this looks gross, but things are going to clean up really quickly, you'll find out. So does the square root of 2 times 5 over 2 minus 5 minus 2 times 5 over 2, does that equal -5? So focusing right here on this multiplication, I'm multiplying by a fraction, but this is a fraction because I'm dividing by 2. Well, what relationship do dividing by 2 and then multiplying by 2 have in common? They cancel each other out. And so this becomes just the square root of 5 minus 5 minus, same story, that 2 cancels with that 2, which leaves me with 5. Does this equal -5? 5 minus 5 is 0. Square root of 0 minus 5. This is going to work, right? Because 0 minus 5 is -5. Boom. It checks. And so since both 3 and 5 over 2 checked, my solution set correctly is both of them. All right, fun times. Number 5. A equals 2, B equals -11, C equals +15. So we're going to plug those into x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So here we go. Negative b is -11 or +11 plus or minus the square root of -11 squared is +121 minus 4 times 2 times 15, all divided by 2 times 2 for my a would have been 4. So 11 plus or minus big square root 121 minus, let's see, 4 times, no, this is what I'm going to do instead. I'm going to choose the easiest math I can do. 2 times 15 is 30. 30 times 4 is 120. Boy, that's going to work out really nicely. Divided by 2 times 2 is 4. So that is 11 plus or minus the square root of 1. Do not forget that 1 is actually also a perfect square. So the square root of 1 is 1 itself. 11 plus or minus 1 divided by 2. As a fraction, that it doesn't look like I can simplify that, but if I consider the plus and the minus separately, that is arithmetic that's going to simplify. So I get that x equals, up top, 11 plus 1 divided by 2. 11 plus 1 is 12. 12 divided by 2 is 6. Ruh-roh. I don't feel like those are the answers that I got. If I do the minus, I get x equals 11 minus 1 over 2, which is 10 over 2, which equals 5. And that's not what I got. So let's hang on a second. I'm going to pause the video and inspect my work. Oh, I figured it out. I'm a dingus. Okay, so instead of like rewinding and trying to edit it out, I just want to show y'all I am human. 2 times 2. 2 times 2 is not 2, it's 4. 4. 4. 4. 4. 4. 4. So 12 divided by 4 is 3. And 10 divided by 4 as a fraction reduces. If I divide out 2's, it's 5 over 2. Okay, so now we're like 3/4 done. Well, those are my two potential solutions for x, but I still have to check them. And so as I was like scooting around, I accidentally inserted a weird slide in a weird place. So I'm going to take, well, you may never have known that, but I'm going to take x equals 3 and x equals 5 over 2, and I'm going to check them to make sure they work. And I'm going to plug them into the original equation. And what I'm going to find out is this is one of those times where they both actually check. So let's see it and let's have fun with it. Let's solve. Hang on. Okay. Let's solve 1 over x minus 4 minus 3 over x plus 6 equals 10 over x squared plus 2x minus 24. Okay, so let's make a note and let's confirm that this third denominator factors as x plus 6 times x minus 4. And we can do that really quickly because x times x is that x squared. 6 times negative 24 is that minus 24. 6x minus 4x is that positive 2x. And what a coincidence, x plus 6 is the denominator I have here. X minus 4 is the denominator I have here. So we said in class that the least common denominator is going to be the product of the distinct factors. So that is, my first fraction has a denominator of x minus 4. So I'm going to have to multiply by at least an x minus 4. But then my second fraction has a denominator of x plus 6. So I also need a factor of x plus 6. My third fraction has a denominator of x plus 6. Well, I've already got that accounted for. I don't have to do that again. And a factor of x minus 4. Well, I've already got that accounted for. I don't have to do that again. So I'm going to take this, and I'm going to multiply this, this, and this by that. And when I do, everything in the denominator is going to cancel with something from the numerator. But I'm going to write out that multiplication first. And for time's sake and boredom's sake, I'm going to pause my video while I laboriously write that out so you don't have to listen to me just ramble. Boom, like magic. There she is. Okay? The one thing that I will point out before I start canceling is I rewrote my third fraction in factored form down here instead of the original. But that's okay because I want to focus on the factors because that's what cancels out. So, first fraction, the x minus 4 on bottom cancels with the x minus 4 up top. Second fraction, the x plus 6 cancels with the x plus 6. Third fraction, x plus 6's cancel, x minus 4's cancel. So what is left over? 1 times x plus 6 is x plus 6. You know what? I'm going to go ahead and write that. It's really not necessary in most cases, but I'm just going to make a good habit. Minus 3 is left over times the x minus 4 equals, the only thing left over now is that numerator 10, so I'm going to write that down. This becomes a linear equation to solve. I don't see any x squareds, no square roots or anything like that, so I'm going to distribute to get rid of those parentheses, except I don't really need to distribute that one. X plus 6 is just x plus 6. Distribute the negative 3. So minus 3x plus 12 equals 10. Combine my like terms. X minus 3x is negative 2x's. 6 plus 12, my constants, is 18 plus 18 equals 10. Solve for x, subtract 18. We can do this. I'm going to do this in my head first, basic. Subtract 18 from both sides. I get negative 2x equals negative 8. Divide by that negative 2. I get x equals negative 4. I was going to make a stupid joke about do I need to flip my symbol around, but flipping an equal sign around just makes it still equals. And then I recall I forgot something in the beginning, but I'm remembering it here at the end. This was a rational equation, which means there was a possibility that some solutions don't check, and that's what happened here. If I try to take x equals 4, negative 4, and plug it in. No, I'm good at math. Negative 8 divided by negative 2 is positive 4. Now, if I try to take x equals positive 4 and plug it in, there, 4 minus 4 is going to give me 0 on bottom. I am not allowed to divide by 0. That's how the x-men were created. So if I'm not allowed to divide by 0, then x is not allowed to be 4. Then I have no potential solutions left. And so my solution set is, there is no solution. There is no spoon. Okay? So remember, our symbol for no solution could also be a circle with a slash through it. You're welcome to write that. Or, and I'm not going to try to make it fit in here, we could just do those empty braces. That also means no solution. All right, the thing that I forgot to do in the beginning that I'm going to go ahead and acknowledge now is I should have looked for my restricted values. And right here, this says x can't equal 4. And here, this says x can't equal negative 6. And then ditto here and here. So if I would have made note of, let me fix this, my restricted values, then it would have been all the more obvious right here that I would have had this problem. But I made the mental check. Does x equals 4? Is it a possible solution? Boom, gives me 0 on bottom, so no. No solution. All right, did I get them all right? I think I did. Okay, well, that was fun. See you guys later.